Okay, today's topic is inequalities. And the great thing about inequalities is that there's a tip. You solve them just like you solve one-step equations. So I'm not going to go too in-depth over how to solve one-step equations because you can go back and watch those videos. But you're solving them just like you solve one-step equations. But there are some little tricks and things we have to remember when we solve inequalities, so I'm going to do that for you today. Let's look at our example problem. We have negative 10 plus some number j, that's our variable, is greater than negative 5. We can rewrite this problem so that it makes a little more sense, because normally our variable comes first, but there are times when our variable is in the middle of the problem. So let's rewrite it. We could rewrite it so that it said j plus negative 10 is greater than negative 5. I could write it like that. It's the exact same. But this is where it kind of gets confusing because this is an addition problem. And I know that I have to take the inverse of addition, which is subtraction, but I have to get rid of that negative 10, and I can't subtract 10 from negative 10 because it's not going to get rid of it. I would have to add 10 to negative 10 to get rid of it. So what's good about this problem is that I can rewrite it another way so that that becomes a little more clear. Remember, subtraction is just adding the opposite. So if I wanted to rewrite this problem, I could rewrite it as j minus 10 is greater than negative 5. J minus 10 is greater than negative 5 is the same as adding, so j plus the opposite of 10, which is negative 10. So j plus negative 10 is the same thing as j minus 10. Let me say that again. Remember, subtraction means you're just adding the opposite. So if I'm adding the opposite of 10, j minus 10 is the same as j plus adding the opposite of 10, which is negative 10. So j plus negative 10 is greater than negative 5. I just want you guys to get that clear, so rewriting the problem can sometimes make it easier. So if our problem is subtraction, then I know the inverse is addition, because that's the opposite of subtraction. Okay? So that means I'm going to have to add to get my answer, to get j by itself. So let's take a look at it. So I rewrote my problem. Some number j minus 10 is greater than negative 5. If I were modeling this, j 10 negatives, because subtracting 10, so minus 10, negative 10, is greater than negative 5. Okay? We said we had to do the opposite of subtraction, which is adding. That's the inverse. And I have to get j by itself. Right now it's attached to 10 negatives. So I need to get rid of those 10 negatives. The only way to get rid of them is to add 10. So I need 10 positives. But if I do that on this side of the inequality sign, then I've got to add 10 to the other side of the inequality sign. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positives on this side. So I need 10 positives on this side, because remember, I got to keep them balanced. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Everybody see that? Now remember, if I have a positive and a negative, they create 0 pairs and they go to the sea of zeros. So negative, positive, negative, positive, and I keep doing that until I don't have any more negatives and positives. And this part's easy because they're all going to go away on this side. And that's how I got J by itself, right? But now I have to do this side. So positive, negative, negative. And then I've got one more. And then I have J, which is left by itself, is greater than, and then I just count how many positives are left, and that's 5. If I was drawing a picture, that's how I would do it. Mathematically, if I add 10 to both sides, because remember I've got to keep them balanced, a negative 10 and a positive 10, we just saw what happens. They cancel each other out, and that leaves me with just J is greater than, I bring the inequality symbol down, and then I have a positive 10 and a negative 5, and we saw what happened with that. That leaves me with 5. So in that example, J would be greater than 5. If I have to put it on a number line, I start off with my number line. I like to make it a little easy, so you only need to put 3 numbers on your number line. The first number is your answer, so you put that directly in the middle. Then you need the number that comes before it and the number that comes after it. So we know 4 comes before 5 and 6 comes after. So those are the only 3 numbers you need on your number line. We need all numbers, so any number that J is, has to be greater than 5. So that's going to be an open circle because I can't have a 5 for J. So that means it needs to be any numbers that are bigger than 5, but it cannot include 5. So we put an open circle on the number 5. And then my inequality symbol points in the direction for all the answers that J could be. So it has to be numbers that are bigger than 5. The arrow is pointing that way, so my arrow needs to go that way. And that's how I would plot it on a number line. So remember, inequalities, the answer pretty much tells you how to make your number line. Let's try another one. This one's going to be a little trickier. Let's say we have a problem that looks like this. Let's say we have -7 minus D is less than or equal to 3. Okay? Here is our problem. -7 minus D is less than or equal to 3, positive 3. Well, remember we wanted to rewrite our problem. We like to have the variable come first. So we have -D plus -7 is less than or equal to 3. Well, how did I get that? Okay, well, subtracting D is the same thing as adding the opposite. So negative d would be the opposite of positive d, and we're adding negative 7. I know, that looks a little messy. I don't like this part either, so let's rewrite it one more time. Negative d minus 7 is less than or equal to 3. That looks a little better for me. I know that this is a subtraction problem. I know that the opposite of subtraction is addition, so I would have to add to get my variable of d by itself. I know that was a little tricky. Stay with me. Remember, all we did is we just rewrote our problem. It started off as negative 7 minus our variable d is less than or equal to a positive 3. I wanted to rewrite that. So remember, subtraction is just adding the opposite. So first, we're going to put the add symbol. The opposite of d is negative d. So negative d plus, and then I had negative 7. But remember, I don't like to have the negative 7 after the plus sign because it does not tell me what is the inverse. So I just rewrote it one more time as negative d minus 7 because that is the same thing as adding negative 7. Okay? I know that's a little tricky, but if you follow those steps, it'll make your lives a lot easier. Okay, so now we know we need to add to get the answer. So let's model it. We're going to have our variable, which is negative d. We're going to need 7 negatives. And that's got to be less than or equal to 3 positives. Okay? Negative d is our variable. 7 negatives less than or equal to 3 positives. We know that this is a subtraction problem. The inverse of subtraction is add, so we have to add 7 to both sides. So 1, 2, 3, 4, 5, 6, 7. And remember, you got to do it to both sides of the inequality symbol because you got to keep them balanced. So we're adding 7 to both sides. Let me do it mathematically too. Just so everybody can see. Okay? Now, remember, a positive and a negative make a 0 pair. So positive, negative. And we know what's going to happen on this side. They're going to go all away, which is the point because we want to get our variable by itself. So negative 7 plus 7, they went away. That left me with just negative d. And then there's no negatives on this side. So I can't make any 0 pairs. So that means I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have negative d is less than or equal to 10. We're almost done though. We can't have a negative d, remember? We have to have a positive d. So negative d is the opposite of positive d. So if I do positive d, then I have to also take the opposite of the 10, which would be negative 10. This is where the tricky part comes. If I had to take the opposite to get it as a positive d, then my inequality symbol has to flip. So it now becomes, instead of less than or equal to, greater than or equal to. That is the one trick. I had to take the opposite of negative d to get it to become positive d, which means I had to do the opposite of the 10, which made it negative 10. But whenever I have to do that, then my inequality symbol has to turn the other way. And so now it is positive d is greater than or equal to negative 10. I know that's a little tricky. Let's do one more and you'll see that again. So the trick is, whenever you have to multiply or divide by a negative number, that is when your inequality symbol flips. So let's say I had negative 2w is less than positive 12. Okay? Remember the tip. If I have to divide or multiply by a negative number, the inequality symbol just flips. Let's draw this out. I've got negative w and negative w, and that's less than 12 positives. Okay. Remember, I've got to take these 12 positives and I've got to split them between my two variables so that I get the same amount in each variable. This is a multiplication problem. Negative 2 times w is less than 12, which means the inverse is division, so we have to divide. That's how we're separating, we're splitting, we're dividing our 12 positives among these two negative w's. So 1, 2, that means 2 go away. 1, 2. 1, 2. 1, 2. 1, 2. And 1, 2. Okay? So each negative w becomes or is the same as 6 positives. Everybody see that? But I can't have a negative w, right? So that means I need the opposite of negative w, which is just w. And if I do the opposite of negative w, then I've got to do the opposite of my 6 positives, which would be 6 negatives. So 1w is the same as 6 negatives. Remember, we just did the opposite of negative w, which was 6 positives. The opposite of negative w is positive w. The opposite of 6 positives is 6 negatives. Let's see it mathematically. I would have to divide negative 2 times w and 12. I'd have to divide it by what's attached, which is negative 2. And I got to do it to both sides. So if I divide negative 2 into negative 2, that gives me 1w. But I divided by a negative number. That's going to split my symbol, which means it has to be greater than now. And then 12 divided by negative 2. I have a positive divided by a negative. That means my answer is going to be negative. And 2 goes into 12 6 times. So 1w My symbol flips because I had to divide by a negative number, or I had to do the opposite, remember? So my symbol flipped to greater than, and -6 is my answer. I hope this has been helpful. I know it's a little tricky, but if you follow it step by step, I promise you'll get it right. If you have any questions, please let your teacher know.